Okay, this is section 7.4, which is on inverse functions. Today's date is 3/27. Okay. And what you're going to do today is you're going to determine the inverse of both a linear and a nonlinear function, and then you're going to verify that two functions are inverses of each other. Now, the word verify means the same thing as prove, so what that second goal is saying is I'm going to give you two different equations, and then you're going to go through the process to show how they're inverses, even though we already know that they're going to be inverses. Okay, so for vocabulary, you need to understand some of these vocabulary words before we start. An inverse function is like the opposite function. In other words, what's the opposite of multiplication? Division. And what's the opposite of subtraction? Hopefully you said addition. How do you undo x squared? You take the square root. Okay, so what do inverse functions do? Well, okay, inverse functions undo each other. And so that's what I was just talking about. How do you undo multiplication? With division. How do you undo subtraction? With addition. How do you undo x squared? You take the square root of both sides. And so that's what we're talking about. We're going to look at inverse functions in several different ways. Now, how to find an inverse. There's two steps, and this is not difficult. The first step to finding an inverse is that you switch x and y. And so you guys may not be able to write on top of the black box, so just write out beside of it. The first step is that you switch x and y. So if we have an equation that says y equals mx plus b, we're going to swap places with x and y. And then the second step is that you have to actually solve for y. We always have to have equations written in y equals form because that's the form that we would type it into our calculator. And so you have to get y by itself. So what do inverse functions do? They undo each other. They undo each other. How do we find an inverse? We switch x and y, and then we solve for y, or get y by itself. So some notation, so that what's going to happen is you're going to have two different equations. You have to be able to tell which one is the original and then which one is the inverse. And so for the original, it's often written, or we see it in function notation, as f of x. Well, I can't call both equations f of x because then you won't know which one I'm talking about. And so to show f's inverse, we write f inverse of x. And it looks like f to the negative 1 power, but when you read that, it says, or you would read it as f inverse of x equals, and then we would go on to tell what the rest of the equation was. So make sure in your notes that you're writing the original is f of x, the inverse is f inverse of x. All right, now about the graphs of inverses. In order to tell by looking at the graph whether or not whether or not two functions are inverses, is that they have to be symmetric about the line y equals x. And I'm going to show you exactly what this means. A function and its inverse are symmetric about the line y equals x. So I want you to think about what the word symmetric means. It means I can fold something in half and it's going to be the same on both sides. So I'm going to show you how that happens on the next page. So here we go. Example number 1, it says find the inverse of each function. Now this first function, remember we learned several different forms that a function can be written in. The first one is given to us in the form of a table of values. So what we're going to do is we're just going to go ahead and graph this original function. In fact, since this one's the original, we'll call this one f of x. So then I'm going to come down here and do f inverse of x, and we're going to make a new table for f inverse of x. In fact, I want f inverse of x to be red, so I'm going to go back over this in red. F inverse of x is going to be red. So go back on that very first page, and we said there are two steps to finding an inverse. The first step is to simply, what did it say? Switch x and y. And the second step said to solve for y. Well, since I don't actually have an equation that's in y equals form, like I don't have an equation to solve for y, all I have to do is the first step, which is switch x and y. So this point right here, 1, negative 1, if I switch the x and the y, what will the new point be? Negative 1, 1. Okay, and so then I'll do the same thing for the next point. If I switch x and y, it's going to be negative 2, 2. Negative 3, 3. Negative 4, 4. And negative 5, 5. I took each point and I switched x and y. So now we're going to graph both. And I'm going to graph the original, the one that was given to you, in blue, and then I'll graph the inverse in red. So all I'm doing is plotting points. This point is 1, negative 1, so I go over 1, down 1. The next one's 2, negative 2, so over 2, down 2. 3, negative 3, 4, negative 4, and 5, negative 5. I plotted the original in blue. Now I'm going to graph the inverse function. That's the red one that we just made. So now graph the point negative 1, 1. And then negative 2, 2. Negative 3, 3. Negative 4, 4. Negative 5, 5. Blue is the original, red is the inverse. And if you go back and read that definition, in fact, let's look at it. Oops. Right here at the bottom of the page, read what it says. A function and its inverse are symmetric about the line y equals x. So I'm going to show you what that means. So we've just graphed both of those. How are they symmetric about the line? Well, the line y equals x is this line that goes right through the origin of the graph right here and has a slope of 1. So imagine that I could take that graph off of the page and fold it in half and make the fold that black dotted line. What would those red and blue dots do? They would lay on top of each other. So that's showing that those two functions are inverses of each other. Now, what if I give you an equation and tell you to find its inverse? So part B, the equation is y equals 3x minus 1. Y equals 3x minus 1. So when I do this, I like to write the word inverse right here because we're getting ready to write another equation, and I want you to be able to distinguish between the original equation and the inverse equation. So what were the two steps for finding an inverse? First, we switch x and y. So if I swap x and y right here, it's going to say x equals 3y minus 1. All I did was change or swap their positions. The second step then says to do what? After you switch x and y, then we have to, what did it say? It says solve for y. So now I've got to get y by itself. So what would you do first? Add 1. So now I have x plus 1 equals 3y. And is y by itself yet? No. So to get y by itself, what do? Have to divide by 3. And I always ask, what do you divide by 3? You divide every single piece. So I'm going to divide by 3 here, divide by 3 here, and divide by 3 here. So what does my final equation say? Y equals, this is the same, x over 3 means 1/3 x plus 1/3. That's the inverse function. That's what you get when you switch x and y and then solve for y. It's not too bad as long as you make sure that you're following your 2 steps. All right, let's try C. Remember, if I start moving too fast, that you need to ask somebody to pause the tape or pause the recording so that you'll have time to copy this down. All right, part C says f of x equals 1/4 x squared, and then there's this comma, x is less than or equal to 0. This information right here, this x is less than or equal to 0, that's not part of the equation in terms of the work. You're not going to work on that. What this is doing is it's giving you information and saying we only care about the inverse where x's are less than or equal to 0. And we're going to come back to that at the end of the equation. So right now I want to find the inverse. And again, we're going to use our 2 steps. And our 2 steps are switch x and y and solve for y. Well, I don't even see a y up there. What's f of x mean the same thing as? It means the same thing as y. So why don't you scribble that out? And we'll put a y there so that we can actually see that it now says y equals 1/4 x squared. If I switch x and y, what will the new equation say? Not y equals, but x equals 1/4 y squared. Okay, well that's the first step, switch x and y. What's the second step? Get y by itself. So, how do I get y by itself? I need to get rid of the 1/4. So I could either, what's happening between the 1/4 and the y squared? Multiplication. Well, how do you undo multiplication? With division, but I don't like to divide by a fraction. So instead of dividing by a fraction, what would I do? I would multiply by the reciprocal. So multiply by 4, or 4/1. That cancels out my fraction. I now have 4x equals y squared. Is y by itself? No. How do I get y by itself? I have to undo the square, so I use square root. So I'm going to take the square root of both sides, and I get y equals, what do you not forget when you take the square root? Don't forget your plus or minus the square root of 4x. Is that how my answer should stay? In other words, could it be simplified just a tad bit more? What number do you recognize under the square root? What could you do? Hopefully, you said take the square root of 4, so then I would write my answer as y equals plus or minus, the square root of 4 is 2. Can you take the square root of x? No, so it's going to stay inside the radical. So y equals plus or minus 2 on the square root of x. This is what brings us, this is where we have to go back to the original. And this is why the x is less than or equal to 0 part is there. Because what they're telling you is they knew from the beginning that you were going to get plus or minus. They knew you were going to have to take the square root. And what they're saying is they only want one of the options. They don't want plus and minus. They only want one or the other. Do you know which one they want? If it's for all values less than 0, then which one do you think that would be? Hopefully you said the minus, because we're talking about values less than 0. And so that would be all negative values. So the answer, and there will be one similar to this on your quiz. No, not on your quiz, I'm sorry. On your test. This material will not be on the mid-chapter quiz that you're taking today. The quiz you're taking today is on 7.1, 7.2, and 7.3. Anyway, but you will have a problem where I'm going to give you a restriction like this up here where it says x is less than or equal to 0, and that way you have to pick between the plus or the minus. I'm choosing the minus because it tells me to do anything less than 0. So that would be all negative numbers. Okay, last one like this, part D. F of x equals 1/3 x to the third plus 2. Again, it's another problem where I don't even see a y value, so how can I do my 2 steps? But what does f of x mean? means the same thing as y. So I now have y equals 1/3 x cubed plus 2. So I'm going to write the word inverse. And then I'm going to do my first step. So if I do my first step, what should I write underneath the word inverse? X equals 1/3 y cubed plus 2. Now, I need to, that's the first step, switch x and y. Second step is get y by itself. So what would I do to get y by itself? What do you have to do first? Remember, you're taking this equation apart, gradually isolating this y. So what do you need to do first? Subtract your 2. So minus 2 on both sides. So that gives me on the left x minus 2 equals 1/3 y cubed. Is y by itself? No, not yet. So I want to get rid of the 1/3. I don't like to divide by a fraction, so instead I'm going to multiply by the reciprocal. Now, let me go back for just a second before we move any further. I'm going to multiply by the reciprocal on this other side, but come back over here to part B. Yeah, follow my pen right here. Remember how we divided by 3 right here to get y by itself? And I said, what do you divide by? 3. Every single piece. The same thing is true on this side when we multiply by the reciprocal. We have to multiply everything on that side of the equation by 3. So essentially we have to do the distributive property. 3 times x would be 3x. 3 times minus 2 would be negative 6 equals y cubed. Is y by itself yet? Not quite. The last step is to get rid of y cubed. How do you undo something cubed? You take the cubed root of both sides, and we end up with the cubed root of y cubed is just y equals, do I need plus or minus on this one? Hopefully you said no. You don't need plus or minus because you're not taking in the even root, you're taking the cubed root. That's odd, so you're not dealing with plus or minus. We just write y equals the cubed root of 3x minus 6. This is the inverse function that we found from the original. So, before I move on to the very last thing, what are the 2 steps for finding an inverse? First, you switch x and y. Second, get y by itself or solve for y. Alright, last thing we're going to do is we're going to verify that 2 functions are inverses. And I'm going to go back to what I said when I read the goal to you. Verifying means I'm going to hand you 2 functions and I already know that they're inverses. You're going to prove it or show me that they're inverses. So 2 functions are considered inverses if we do the following 2 things. We have to say f of g of x equals x, and we have to do g of f of x, and it also has to equal x. So yesterday we talked about how to do composite functions. That means we're going to take an equation and put it inside of another equation. And we have to do that twice, and both times our answer, after we put one function inside of another function, has to come out equal to x. So let's just try this first one, part A. Verify that f and g are inverse functions. That means we already know they are, but we're going to prove it. And we have to do it 2 ways. First, I have to take 2x minus 2. If you want to put that in a box, it might help you. And I have to put it inside the other equation. I have to plug this 2x minus 2 in for x into the other equation. So in other words, what I'm saying is f of g of x. Well, what is g of x? It's the stuff we put a box around. So f of 2x minus 2 equals, now I have to plug that in on the other side too. So 1/2. Now, whenever I put something and I plug it into an equation, what do I need to put around it? Parentheses. I'm going to put 2x minus 2 in there, and then go up here and look. That's not the. We got to finish the rest of the equation where it says plus 1. Now, guys, this side right here, where you said f of 2x minus 2, you don't have to do any work to that side. You're just showing me what you're doing right now. So the only work we have to do is on this other side of the equation. Well, if I'm trying to simplify or work out the other side of the equation, what do I need to do with that 1/2? I've got to distribute it into the parentheses. So 1/2 times 2x, what's half of 2? It's just 1x. 1/2 times negative 2 is minus 1. And then I got to bring down my plus 1. So I get x minus 1 plus 1. Well, what's going to happen to the negative 1 and the plus 1? They're going to cancel out, and I get equals what? Just x. So look, up here at the top, f of g of x had to equal x. We just showed that f of g of x equals x. Well, now I have to go the other way. Now, I'm going to use a different color, so let's erase this box right here, or I'm going to, and erase these little arrows. Now we have to go the other direction. This time, who goes in the box? 1/2 x plus 1. Because now, look up here, it says g of f of x. I have to take this equation and put it in for x on the other one. So, I'll put a line right here so you can see. What am I going to write? Make it look just like this equation. Instead of f of, I'm going to write g of. This equation in the box, in the red box, is going in for x. So g of 1/2 x plus 1 equals 2. Whenever I plug something in, now I'm plugging in for this x up here. 1/2 x plus 1. I got to put parentheses around it and then bring down the minus 2. Now, do I do any work on this side of the equation? I hope you said no. We don't do any work on that side. That side is just telling me what we just did. Now I'm actually going to work out on the other side. And what should the answer be when I work it out? Hopefully you said x, because both of them have to work out and equal x. So 2 times 1/2, or 2 times 1/2 x would just be x. 2 times positive 1 would be plus 2. I just had to distribute that 2 that was outside the parentheses. Now bring down the minus 2. Again, what do you see that happens? Positive 2 and negative 2 cancel, and all that's left is x. So I took f, plugged it into g, and got x. I took g, plugged it into f, and got x, and that proves that those two equations are inverses of each other. And that's what the directions mean when they say that verify f and g are inverse functions. All right, last one. Let me clear this off. All right, we have f of x equals 8x to the 3rd power, and g of x equals x to the 1/3 divided by 2. So we're going to start just like we did last time. I'm going to do f of g of x, this right here, first. That means which one goes on the inside? G of x. So I'm going to put this in the blue box, and I'm going to plug it in for x in the other equation. So I have f of x to the 1/3 over 2 equals, oh, I made my arrows too long. Now I'm not going to do any work on this side, remember, we're just showing what's happening right now. On the other side I'm going to say 8 parentheses, what goes in the parentheses? X to the 1/3 divided by 2. And don't forget that cubed part right up here. So those parentheses were cubed. So this is why it was so important that you learn the properties of exponents, because you're having to use them right now. The properties of exponents, what do I do with this exponent 3 on the outside of parentheses right here? I have to distribute it. Well, what do I do when I say 1/3 times 3? Or what do you get when you do 1/3 times 3? You just get 1. So we have 8. I'm just bringing the 8 straight down. When I distribute that 3 times x to the 1/3, I just get x to the 1 all over. But you got to remember, you got to distribute it down here to the 2 also. What's 2 cubed? I hope you said 8. Well, now this 8 that's out here in front by itself, what's it really over? 1. When I have the same number on top and bottom, what do? They cancel, and all I get is x. We knew that was going to happen. We just had to show the work on how to get there. Am I done? No. Now we have to go the other direction. Now we have to take the f of x function and plug it into g of x. All right, so I'm going to switch colors to do that one. All right, so now this is what I'm doing. G of f of x. Who goes on the inside? F of x goes on the inside, so that's what we're going to put in our box. And we're going to plug it into the other equation for the x. So I'm going to write it as g of 8x cubed. That's the side I don't do any work. I'm just showing what it is that I'm doing. And then equals, remember when you plug something in, you put parentheses around it. So something to the 1/3 all over 2. And what we're putting in there in those parentheses is 8x cubed. Well, we sort of just did a problem like this. If you have this exponent on the outside of the parentheses, we've got to distribute it inside. 8 to the 1/3. That's the same thing as what? The cubed root of 8. What is the cubed root of 8? It's 2. Then we have x cubed to the 1/3. What do we do with those two exponents? We multiply them. Well, 3 times 1/3 is just what? It's just 1. So I get x to the 1 power all over. We don't do anything to that 2 because it wasn't in the parentheses. Now we notice there's 2 on top and 2 on the bottom, so I cancel. And I get x, which I should have because the problem tells me if they're inverses, then they both have to come out when I do f of g of x and g of f of x to equal x. Okay. Make sure that on the first page of notes or somewhere in your notes that you've got it written down that you can omit numbers 48 through 56 even. Now I think the assignment goes through 58, so I still want you to do 58. You just omit 48 through 56. What are the 2 steps for finding an inverse? Switch x and y, solve for y. Inverse functions undo each other. So if I want to undo y squared or x squared, I take the square root, which is what we did on that page. Here you've got to show both ways by putting f into g and then g into f. Okay, you're going to take your quiz now. Make sure that you worked really hard to get your quiz done. It has to be done before you leave, and then your homework assignment for the weekend is just section 7.4.